Okay, so that has 4 terms, because if we remember in the very beginning of the year, we talked about the terms of the pieces of an expression that are separated by addition or subtraction. So that has 4 terms. So when we factor by grouping, we group the first 2 terms with the last 2 terms. So I'm going to group first 2, last 2. And then I need to find the GCF of each of those groups. So the GCF, the greatest common factor. Okay, so I'm going to find the GCF of, first start with the numbers and then you look at the letters. So 6 and 16. The GCF of 6 and 16, what would it be? I'll let you guys chat it to me because you guys should know GCFs. Nobody's going to talk to me. Okay, I got one. All right. Okay. All right, so it is 2. So Torian got it. Okay, so it is 2. And so the 3, I got a 3. So 3 goes into 6, but it doesn't go into 16 evenly. So just make sure you think about both of the numbers. So it is just 2. That's the only number that goes into both. So we're going to factor out a 2. And then we're going to decide if they both have x's. If they both have x's, then that means I can at least take out one x, but you can actually take out the smallest number of x's that there are. And the smallest number of x's would be this 2 right here. So there's 3 here, 2 here. So that means that I can take out x squared. So we're finding that GCF of the first group. Then I'm going to open up parentheses and see what would be left. Well, 2 times what would get me back to 6? 3. And then I took out 2 x's right there, took out 2 x's, but I need to get to 3. Okay, so that means, so we see that, so I took out 2 x's, and then I need to get to 3. So that means that I need to write 1 more x there. What would get me to negative 16 would be 2 times negative 8. And I already took out that whole x squared. So that means I don't need any more x's on that with that 8. So I'm ready to close my parenthesis and move on to the next one. Okay, so then I need to find the GCF of 21 and 56. 21 and 56. So if you guys want to chat that to me, I need to find the GCF of the next group. So I drop the plus, find the GCF of these 2. So it is 7. And I saw that in the chat as well. So it is 7. And then this one over here, the 56, doesn't have an x. So that means I can't take out any x's. So I open up my parenthesis. And now with factoring by grouping, the goal is that I get a common binomial. And if we remember, binomial means 2 terms. That means I want it to look like this right here. But you can't just write that. You have to make sure it's right so that your numbers are right. Okay, so it would be 7 times what gets me back to 21x? Well, 7 times 3 is 21. The 21 had an x, so I need an x. And then positive 7 times what would get me to negative 56? Negative 8. And that's exactly what we needed because we have our common binomial. And once we have our common binomial, we're going to drop it down 1 time. So we rewrite it 1 time. And then we're going to take those other 2 pieces, the GCFs, and we're going to make them into their own parenthesis, their own factor. And we would drop that 2x squared plus 7. And then you can write it either way. You could have also written 2x squared plus 7 times 3x minus 8, whichever one you wanted to do the same thing. Okay? So that was the basics of factoring by grouping that I taught you guys in the video. So again, hopefully you guys watched that and that helped you. So the reason we had to know those skills was so that we could do the X method. Okay, so let's try the X method. So we have 3x squared minus 20x minus 7. So this is a quadratic function. Okay, so this is a quadratic function because its highest exponent is 2, and it's a trinomial. Okay, so that means, there's 3 terms, trinomial. So that means I can use the X method. And so for our X method, we create a big X, And in the top of the x, we're going to write our a times c. Okay, and if we remember, this is ax squared plus bx plus c. So a times c would be this 3. Get rid of that. Would be the 3, positive 3 times a negative 7. Okay, so 3 times negative 7 is negative 21, and we'd write that up here on the top. So that, again, this is the one review question we're going to do for that first section of the work before we move on. Okay, so we write negative 21. And then at the bottom, so let me just, for those of you that weren't here the other day, and if you didn't watch the video, the top is a times c, the bottom is b. Okay, so at the bottom, we're going to bring over our b. Well, our b is this negative 20. So you have to remember the sign in front of a number belongs to a number. So it's negative 20. Okay, and now I need to find the things that multiply to give me the top number. And then because that's a negative, they're going to subtract to give me the negative, or the bottom number. If it was a positive, they would add to give me the bottom number. If it was since it's a negative, it's going to subtract, okay? So we're going to break apart, we're going to find the factors of 21, kind of like what we did last week. So 21, we're going to break it apart. 21 would be 1 and 21. 2 doesn't go evenly, but 3 does. 3 and 7. 4 doesn't. 5 doesn't. 6 doesn't. And we're back at 7. Okay? So then, because that's a negative, we need to decide which one of those sets of factors will subtract, because it's a negative, subtract to give me the 20, the b. 20, what would it be?
1 and 21.
It would be 1 and 21. So we're going to take that 1 and 21, we're going to keep that in our head, and then we need to look at the sign of our b will tell us the sign of the bigger number. Okay, so that means that the 21 would have to be negative and the 1 would have to be positive. And then I'm going to take those numbers and I'm going to rewrite them in my x. So positive 1 and a negative 21. Okay, so the x is just to kind of give you something to work with to compartmentalize your processes. Okay, because on Khan Academy, he does this, but he doesn't like give you any way to like think through it. He more kind of makes you challenge your own brain and not have a way to write it out. So this is a way you could write it out. Okay, so once we get those pieces of the x, then we're ready to rewrite our original equation, but we're going to break apart this b with these values that we just found. Okay, so we're going to drop it just like we see it. We have 3x squared, but instead of negative 20x, we're going to write plus 1x, or just plus x. If you want to write the 1, you can. Minus 21x minus 7. So you drop the a and the c just like you had them. But then we're going to break apart that middle piece with these numbers over here and just put an x with them. Okay, so mathematically we didn't change the equation, because if I were to add those back together, like if I were to put these back together, it would get me back to that 20. So I didn't change anything mathematically, so it's okay, we can do this. But now that we have 4 terms, we now have to do the factoring by grouping, the thing we just reviewed. So we group the first 2 and the last 2. Okay, and then I need to figure out the GCF of each of those. So the GCF of 3 and that invisible coefficient of 1. Well, it'd just be 1. But both of those share an x, so I can at least take out 1x. So I'm going to take out an x. And then if I'm going to redistribute that back in, so it's kind of like I'm undoing that distributive property, then I would have x times what gets me back to 3x squared? Well, it'd be 3x, because there was 2 x's here, and I only took out 1, so I needed 1 more. Okay, then x times what gets me back to positive x? So this is the piece that sometimes students will forget. what do you multiply something by to get back to itself? That is a question you guys can answer.
A negative?
No. What do you multiply something by to get back to itself? So like x times what would give me x? Or 2 times what would give me 2?
1.
1, yeah. I saw it on the Braille too. Or as well, not the number 2. Okay, so x times positive 1 would get me back to, let me take away those. X times positive 1 would get me back to x. So you still have to use 1 as a placeholder sometimes, okay? All right, so then I'm gonna drop that negative, and then I need to decide the GCF of 21 and 7. 21 and 7. What would their GCF be? Let's go ahead and use the chat since we have a few more people in here today. No, I guess no, we don't. Just kidding, they left. So, but I want to hear from other people than just Taj, because Taj, I know you know this from Tuesday. Who else can tell me the GCF from 21 and 7? Yeah, Torian. It's okay, so 7.
Oh no.
It is 7. And then this doesn't have an x over here. There's not an x there, so I can't take out an x. Okay? So then I'm going to open up parentheses. And then 7 times what gets me back to 21x?
3.
3. And then I need that x there. Yep. And then this is where we have to be careful, because this is a negative 7. So negative 7 times what gets me back to negative 7?
1.
What kind?
Negative 1.
Ooh, a negative times a what gives me a negative?
What?
A negative.
Wait, hold on, wait. No, positive 1.
Positive 1. Which is what we needed. We wanted to be able to see this common binomial right here. So we got it right. We have a common binomial. So we're going to drop that down one time. 3x plus 1. And then we're going to take the other two pieces, the x minus 7, and write them in another factor. And that would have been your final answer. So this would have got us all the way back up to that. So what difference of squares looks like is it's when we have like x squared minus a squared. Okay, so it means that we have two numbers that are perfect squares. And on Tuesday, we kind of started talking about this, but like, let's think about what some of our perfect squares are. And so this would be something good to write down because I don't think a lot of you have these numbers memorized yet. So like 1 times 1 is what?
1.
1. 2 times 2 is
4.
3 times 3 is
9.
4 times 4 is
16.
5 times 5 is
25.
6 times 6 is
36.
7 times 7 is
49.
8 times 8 is
64.
9 times 9 is
81.
10 times 10 is
100.
And then we'll just put it up here. 11 times 11 is, can y'all still see that on my screen? Or is that too far off?
11 times 11. 111.
Not 111. Can y'all still see that? Yes or no?
121.
It is 121.
Oh, dang.
Victoria, you got it as well. 121. And then 12 times 12 is?
Break out the old book.
144, yep. Saw it in the chat.
Yeah, 144.
Last one, the last major one, the one that you will always be expected in math, all the way up to college math. They're going to expect you guys to be able to know these pretty quickly, your perfect squares, all the way up to 13. What's 13?
169.
169. Yep, 169. Okay, so those numbers, okay, so these right here, 1, 4, 9, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. When you see those numbers, if you can get in the habit of recognizing that's a perfect square, it will save you so much time, especially on factoring, okay? Because if this problem, this x squared minus a squared, so like the strategy is, if it looks like that, if it's two perfect squares, then that means that we automatically can just write x plus a, x minus a. So it's like you take the square root of each one, because the square root of x squared is just x. Okay, because the square root and the square cancel each other out, so it's whatever is left on the inside of the little box. Okay, so if you know that shortcut and you know your perfect squares, then you just saved yourself a whole lot of time. Okay, so let's say it looked like x squared minus 9. Is 9 a perfect square?
Mm-hmm.
Yeah. So what is the square root of 9?
3.
3. It's one of those numbers right there. Okay. So then that means that we could automatically jump straight to our factoring would be x plus 3. Oops. X minus 3. And you're done with your problem. You factored it. Literally it. Okay. Did you guys have all this written down, or did you take a screenshot of this so that you can have your perfect squares?
1 second.
Yep. I wrote it down.
Okay. I'll give you a second so you guys can either take like a screenshot of your computer screen or your phone, wherever you're on, and then, or write it down.
All right.
And then we're going to practice a couple. Anthony, Jaden, you good? Haven't heard anything from y'all.
Wait, Miss Smith.
Yeah,
You said they haven't told you anything about the grading rubric.
correct. I have the grading rubric for your like final exam. And that's the only thing that they've officially like told us how we can grade. So like in terms of like all the assignments that you're doing, like they're still trying to decide like if we should be putting it in the grade book and counting it as like numerical, or if we should be like just collectively looking at things and deciding if it's going to pass, fail, etc. So it's all a mess. And the thing is they're not thinking about, like, just to be honest with y'all, they're not really thinking about like high school and your GPAs and things like that when they're making these decisions. And so like some of us at the high school are really giving them pushback and like, hey, no, they need accountability. They need to do this for their GPA. So we're trying to figure it all out and get you guys where you're in a good position for next year, and that the students that work are rewarded and the students that don't work are not. So it's all a mess, but yeah. Does that kind of make sense?
Mm-hmm.
Okay, everybody got it now? Okay, so let's try a couple of those. So like, let's say I gave you x squared minus 169. Well, what's the square root of 169?
13.
13. So as soon as you recognize that that's 169, that's a perfect square, and it's difference is subtraction. Okay, if it's addition, that's not. Okay, difference is subtraction. You have to know that word. Okay, so since once you see that it's a subtraction and it's a perfect square, then we automatically can go x plus 13, x minus 13. And technically you could write it either direction. And you're done. Okay, so you guys try this one. X squared minus 81. So it's subtraction. And then we know that 81 is a perfect square. What's the square root of 81?
9.
9. So we literally write the x one time plus 9. And then you open up another parenthesis, x minus 9. So just make sure whenever you write it that you guys, when you type these into Khan Academy, that you write there should be 4 parentheses. 2 around the first one, 2 around the second one, okay?
Okay.
It's not my city.
Okay, so that is exactly that. Now let's look at, like, sometimes they might look like this. Let's do darker color. 4x squared minus 81. So when it looks like this, if the number in front of your x squared is still a perfect square, you can do it as well. You can still do this trick. Okay, because what is the square root of 4?
2.
2. And the square root of x squared is what?
2.
I just showed you guys earlier. The square
Itself.
the square root of itself, or just x, yeah. So then I can drop down an x.
Oh yeah.
Plus, what's the square root of
2x
81?
plus 9.
9, and
Minus
then
9.
rewrite it.
Yeah, then parentheses 2x minus 9. Yeah.
Yeah, so even whenever there's a number in front of that x squared, if it's still one of your perfect squared numbers that we listed just a minute ago, then you can still do the same strategy. Okay? So let's think about, what if it was flipped around and it was 16 minus 49x squared? What do you think? Is it still a subtraction?
Yeah.
Yeah, are 16 and 49 perfect squares?
Yeah. Yes.
Yes.
4 times 4 is 16, and
Yeah, 16 and 49. Okay, so then we can open up our parentheses. What's the square root of 16?
all right. So we got 4 plus 7x, and then parentheses 4 minus 7x.
Perfect. Okay, so you take the square root of the 16, and that's going to give you the 4. Then you do your pluses and minuses. Set 7, that came from the 49, and then the 1x. Okay, so the one mistake that sometimes students make is to try to add like a little squared here. But remember, you separated your x apart, so you can't put that there. It's just 1x. Okay? All right, so one more thing that you might see is sometimes you might have to like get your GCF out of the way to be able to see that it's a perfect square. So for example, 2x squared minus 162. Okay, so is 162 an even number?
No.
No.
Even number? Even numbers?
Yeah.
Yes.
Yeah,
Yes.
it's an even number, and all even numbers can be divided by 2. So when you see an even number, you should, or 2 even numbers, you should automatically think that you can at least pull out a 2, maybe something bigger. So the GCF between 2 and 162 is 2. Okay, so on this one, if I factored out the 2, just to make it simpler, to get rid of all those extra common factors, because those complicate it, they make my numbers
X plus
big.
13.
So then it would be x squared minus what? What is 162 divided by 2?
13.
No.
Oh, wait.
You're thinking of 169. This isn't a perfect square this time.
Oh,
We're
yeah.
just factoring out the 2. We're getting rid of the GCF. So what is 162? If I were to put that back, would it be, like, I'm unmultiplying it, so divide it. What's 162 divided by 2? Yeah, Tori, 81.
Calculate. Try hard.
Okay. So now do you see a perfect square?
Mhm.
Yeah, so now we can do our perfect square trick. So we're just gonna drop that 2 down on the outside and then open up our 2 parentheses. It would be x and x plus and minus, and then what number?
9.
9, because the square root of 81 is 9. Okay. And if you understood those, that's that whole middle, that second section of problems this week. Perfect squares. Okay, so perfect squares. Okay, this is the third section this week. Okay, so perfect squares is where you have an A that's a perfect, that would be like a squared number. x squared plus b. You don't have to really, there's not like an actual necessarily formula for this, but that's kind of what it would look like. You would see an a that's a perfect square and a c that's a perfect square. Okay, and but then it's still gonna have these, it's gonna have a plus sign right here. So that's the difference, is this time with difference of squares, there was only 2 pieces and it had a minus in between, because if you were to factor those out, those middle terms would go away. They would become 0 and go away. But with perfect squares, the middle term is still there and the last term is gonna be a positive every time. Okay, and then your A and your C are gonna be perfect squares. So let me show you guys one of them. So if I gave you guys 9x squared minus 12x plus 4. So technically we could do that x method that we learned about with a problem like this, okay? So let's practice the x method and then I'll show you the shortcut and then we'll practice the shortcut some more, okay? But I want you guys to first of all recognize what the difference, so when you first see the x method, if your thing, or to think about doing the x method, is that you don't have a coefficient of 1, a leading coefficient. So you automatically should think x method. But what I want you guys to start thinking through now is, do I have a perfect square? Well, is 9 a perfect square?
Yeah.
Yeah, what's the square root of 9?
3.
3. Is 4 a perfect square?
Yes.
Yeah, what's the square root of 4?
2.
2. So when those two terms are perfect squares, there's a shortcut you can use. But I'm going to show you that if you don't learn the shortcut, you can still use the x method every time. Okay, so we're going to practice x method, then I'll show you the shortcuts. Okay, so x method, I need to do what first? Multiply
A and C.
A and C. So 9 times 4, what is that? 9 times 4.
36.
36, yep. And then that's a positive 4, so it's positive 36. Okay, and then in the bottom of my x, what goes there?
Negative 12.
Negative 12, yeah, the b. Okay, so then I'm going to break apart my 36, and I'm going to find, because it's a positive 36, then that means I'm going to find the numbers that add to give me 12. Okay, so 36, I have 1 and 36, 2 and what?
Oh, wait, huh?
I'm breaking apart 36, finding the factors. 1 and 36, 2 and
18.
18. Remember, you guys can always check your factors. Go to your calculator on your phone. 36 divided by 2 equals. Then you do 3. 36 divided by 3 equals 3 and 12. 4 and what?
9.
Mm-hmm.
Bro, what am I doing?
Does 5 go evenly?
No.
Stevie, you still have a calculator on your phone even if you have an Android? Every phone has a calculator. It just will look a little different.
Androids don't.
And if you don't, download an app because there are free calculator apps. Okay, and then does 6 go evenly?
Yes.
6 and
6.
6. Okay, and so then since we started repeating, we're done. It's okay. All right, so, sorry, I saw the chat. It's okay. All right, so with the, so now because that 36 was positive up here, we need to find the ones that add to B12. Add to B12. Which ones add to B12?
Six and 6.
Oh, add the B12?
6 and 6, yeah, I heard it.
Yeah.
6 and 6. And then because this is a negative, that means they both have to be negative. because -6 minus 6 would give me -12. Okay, so then I'm going to fill in my x, -6, -6. Okay, so now we're going to rewrite remember this is the x method, but I'm going to show you a shortcut in a second. Okay, so we're going to rewrite this 9x squared minus 6x minus 6x plus 4. Okay, so then what would I do if I were using the x method to solve this?
Group them.
Group them, yep, first two, last two. Then find what?
Find the well, you don't distribute. No. Oh.
Find the
Greatest common factor.
GCF. Yep, the greatest common factor. So I need to find the GCF of 9 and 6.
3.
3.
And
how many x's can I take out?
3.
Ooh.
2.
The smallest number that they share.
1.
1. This one has 2. This one only has 1. So I can only take out 1. Okay. So then 3 times what will give me back to 9?
3 times 3.
And then there were 2 x's here, so I need 1 more. Then 3 times what will get me back to -6?
2.
What kind?
Negative.
-2, and then I already had my x, so we close our parenthesis. Drop that minus. GCF of 6 and 4.
Oh, 6 and 4. 2.
2.
Wait.
Both equal numbers.
Yeah.
2.
Yeah. 2 and
Do they both
2.
have an x?
No.
No, so you can't take out an x. Okay, so 2 times what would give me back to 6x?
3.
3
X.
x. And -2 times what would get me back to -4? I'm sorry, +4.
-2.
-2. Which, is that what we needed? Does that give us our common factor?
Yep.
Yeah, our common binomial right there. 3x minus 2 and 3x minus 2. So we drop that down one time. And then I'm going to go get those other pieces. 3x ooh, what happened?
They're the same binomial.
They're the same exact binomial. So whenever we write that, or so what just happened here is that this is what we call a perfect square. So if we saw that there was a 9 and a 4, so there were, the A was a perfect square, the C was a perfect square, and that C was positive, then this is exactly what happened here, is we actually, our answer would have looked like this, 3x minus 2 squared. That would have been the simplest way that you could have written that, right there. So technically, if you don't understand this shortcut I'm about to show you, you can still use the X method on all of these. But if you know this, if you can follow along with this shortcut and you know your perfect squares, then literally this section should be a breeze for you, okay? So let's kind of back up now and I'm gonna rewrite this problem, and now that we know the answer, so do you guys have this down?
Mm-hmm.
Mm-hmm.
Anybody need me to wait a second to take a screenshot or something? Okay, so now we know the answer, so let's figure out how we could have got there using our shortcut, okay? So the problem was 9x squared minus 12x plus 4, okay? So if we were to open up, if we see that the 9, we know that's a perfect square, and this is a positive 4, and 4 is a perfect square, here's how we do the shortcut. We take the square root of the A. What's the square root of 9?
3.
3. And that x, which would just give me 1x. Okay? And then the number at the end will be the square root of this number. What's the square root of that number?
2.
2. And then the sign in the middle is whatever the sign is right there in front of your b. And then you square the whole thing. Was that the answer we got?
Yep.
Yep.
Yeah. So it's gonna, your final answer will always look like a x plus or minus c squared. Okay. So the square root of a and the square root of c all squared, and then the plus or minus comes from your b term. Okay, so let's try another one. So if we had 81x squared plus 180x plus 100. Okay, so if we add this one, what's going to be different, or what's different this time?
There's a positive.
It's a positive, so that this time the positive in front of the b just means it's going to be plus. That's the only thing this time. So the first thing we need to look for when we see problems, especially with numbers this big, because I don't want to try to find the factors. If I were to do the x method, that would be 8100. Do you want to have to try to find the factors of that?
9x plus 50.
Okay, I'm try to find those factors. I don't do it. So we need to find, if we notice that these are perfect squares, then we can do our shortcut. So are 81 and 100 both perfect squares?
Bro, which one y'all?
Okay. All right, I muted all of you trying to figure out who that was. So if you are going to answer my question just a second, then you can feel free to unmute yourself whenever, if I ask another question that you need to answer, okay? So are 81 and 100 both perfect squares? Were they on our perfect squares list? Yes or no?
What was the question again?
Are 81 and 100 both perfect squares?
Yes.
Yes, they are. Okay, so then that means and then this 100 is positive, so that means I can use my shortcut. So I'm going to open up my parentheses, and then I need to do the square root of this section right here. Okay, so what's the square root of 81?
9.
9, and then there was x, the square root of x squared is just...
Isn't it 9x plus 50?
9x, not 50. And then that's a plot.
Oh, 10.
So it is going to be plus. And then what's the square root of 10? I mean, I just said it. What's the square root of 100?
10.
10. And then you put the little square at the top. Isn't that so much easier than the thing we did the first time?
Mm-hmm.
Yep.
Yeah. So if you know your perfect squares, this is your shortcut every time so that you don't have to do the x method. Okay? Is 25 a perfect square?
Yes.
Yes, it is on my list of perfect squares. Is 9 a perfect square?
Yes.
Yes, it is on my list of perfect squares. So that means and then is that 9 positive?
Yes.
Yes, so we have our shortcut. So we open up our parentheses.
Oh, this is easy.
And then we decide the square root of 25x squared would be what?
5x.
5x.
Isn't it minus?
Then it's minus. Why is it minus?
Because the little sign right there in between. Yeah, right there.
The sign in front of b, yep, is minus. So it's going to be minus. And then we take the square root of the 9, which is what?
3.
Squared. Don't forget that. That's the big mistake. Students will figure this out and then forget that and be like, why am I getting it wrong? Because that just means 5x minus 3 times 5x minus 3. We already did special products. We did this like 2 weeks ago where they gave you this right here and you had to break it apart and then multiply it. But now we're unmultiplying, so we're like going the reverse way, and we're trying to figure out, well, how did we get here? Or how did we get the opposite? Like, what's the opposite direction of what they gave us the answer? How can we get back to the multiplication? Okay, so just don't forget that 2, okay? So let's look at one. There's a couple, sometimes Khan Academy will flip it around on you guys, and it will look like this. 1 plus 12x plus 36x squared. Okay, they like to flip things around. You don't see that often, but you will sometimes on Khan Academy. Okay, so it's still the same thing though. The x squared term is still your a. The c is still the one that's your constant, the one that's by itself. Okay, so is 36x squared a perfect square?
Yes.
Yes. Is 1 a perfect square?
No. Well, yeah.
Yeah, 1 times 1, right?
Yeah.
Yeah, so it is a perfect square. So, and then is the sign in front of the c, the number by itself, positive?
Yes.
Yes.
So it's still the same rule, it's just flipped around. Okay, so when we write it, they should count it either way, but they probably want you to write it they probably want you to write it as it comes, so like reversed. So then we're just going to do it the reverse way. So the square root of 1.
1.
1. And what would the sign in the middle be?
Plus.
Plus. What are you, or which sign, plus sign told you that though?
The one right next to
the
Next to the what?
the 1.
Love.
I'm talking about 1 plus 6x squared.
Okay, so it's the one in front of the I think Ernest said it. Ernest, what did you say?
The one in front of the 36.
Oh no, you said a different number a second ago, didn't you?
I'm changing it up. I thought it was wrong. I said 12
You
first.
said the 12 because the 12 is the B.
Alright.
So it's whatever number's in front of B is going to tell us the sign. Okay, so you have to know that your coefficient, your middle coefficient. So it is a plus sign. And then the square root of 36.
6x.
6. And then at 1x with it. And then what do you need
Squared.
after that?
Squared.
1 squared.
That's it. Okay, that is perfect squares. What questions do you have on perfect squares?
Just when it's reversed, I guess.
So you want to try another reverse one?
Sure.
Okay. 100 minus 140x plus 49x squared. Okay. So again, our A and our C, so the number in front of x squared and the number by itself, are they perfect squares?
Yes.
And then, is my C positive?
Yep.
Yeah.
Yes, because it doesn't have anything in front of it. So then we are ready to use our shortcut. Okay, so go ahead for a second. I'm gonna pause and I want you guys to take a guess. You can either write it in the chat or just wait to answer me. Let's see if you guys can figure this out. And you can also ask me a question at this time if you need to. Jaden, you've still been quiet. You good? You there?
I know I got the answer.
Taj, now you see why I didn't really focus a lot on these probably last time, because they're pretty quick once you get them. That's why I wanted you guys to make sure you understood the other concept, because that was the harder one this time. Yes, Taj. Yes, Ernest.
I got it.
Okay. Thanks, Jaden, for letting me know. Do you know how to chat on the deal?
My name is Braylon.
Not you. Jaden messaged me after
Oh.
that's my name.
Oh.
Okay. So what's the answer?
C is 10. 10 minus
10 minus what?
7x squared.
Yeah. Is that what you got, Braylon? Is that what you got, Daylon?
Yes.
Okay. So we take the square root of the 100 and we got the 10. Then the b is a minus, so that's why it's minus. And then the square root of 49, or 49x squared is 7x. And then we put the squared on the outside. Perfect. Now, just to test ourselves so you guys can see where this comes from, let's shirts and pants this out so we can see the final answer. So if we were to go back to special products and rewrite that like that, and then shirts and pants. So 10 times 10 is what?
100.
100.
100. And then 10 times negative 7x is what?
Oh my God, 70.
What kind of 70?
Negative.
Negative x. Yeah, because that's a negative 7. And then negative 7 times 10 is what? Negative 7x times 10.
Negative 70.
Negative 70.
70x. And then negative 7 times negative 7, or negative 7x times negative 7x.
49.
49, positive 49.
Positive 49x squared. And so then we would drop that 100 and combine these like terms, and negative 70 minus 70 would give me negative 140x. Drop that plus 49x squared. Is that what our original answer was? Our original question was?
Yeah.
Yeah. So we did right.
Mm-hmm.
Like that?
Yeah.
Okay, so in these ones, all you have to do is factor out the whole area, because if you know that area means length times width, then that means it's the two pieces that are multiplied together. Well, they already gave you the width. So it only wants to know one of the factors, the factor that it didn't give you, okay? So you could either use your brain and try to guess and check, or you could do X method, and which would probably be your better, safer way, is to use X method, or like your multiplier A times C, figure out what adds to B. Okay, so let's look at that. So if we have x squared plus 8x plus 15. So let's just practice you want to practice x. This one has a coefficient of 1, so there was a shortcut for this one that I taught you guys, where if you multiplied the A and the C, and then you found the factors of C that added to B. But technically you could do this one like with that X method as well. Which method did you like better? The shortcut when the coefficient's 1, or the X method?
X method.
What?
X method.
Okay, so then what's the coefficient of that X squared?
1.
1. Okay, so then if I multiplied A times C, 1 times 15 is what?
15.
15. Yep. Okay, and then what would my B be? What would go in the bottom of my X? What would go in the bottom of my X? What's the B of this right here? What's the B?
8.
Positive 8. Yeah, it's that positive 8. Right? Yep. So then 8. So now I need to find the factors of 15. And since this was a positive and a positive, it's positive 15. So the factors, or the things that multiply to give me 15, and add, because it's positive, add to get me 8. So let's break apart 15. So 1 and 15. Does 2 go evenly? No.
Wait, huh?
No.
But
Nah.
3 and what?
5.
5. Does 4 go evenly?
Mm-mm.
No, it's
No.
back to 5. So I'm good. That's the only ones. Does that far make sense so far, Ernest?
Yeah.
Okay.
Kinda.
And so then, because it's a positive 15, we're going to figure out what will add to get me to the 8. Well, it's going to be my 5 and 3, or my 3 and 5, whichever way. And then it's a positive 8, so that means they're both are going to be positives. Okay, so I'm going to rewrite those up here, plus 3 plus 5. Okay, and then we can rewrite that original polynomial up here and go x squared plus 3x plus 5x plus 15. Okay? And then we do what?
Oh, dang. Why is she ringing the doorbell so much?
And then we do what?
Oh, I think we, hold on.
Do the
Starts with a G.
Groove common.
Group.
the
And then we can find the GCF. Group them. Okay, so we're going to group the first two and the last two. Okay, on that first two, the GCF of x squared and 3x would be what?
3x.
Ooh, there's not a
Oh.
3 in the first one. It's just a what? What's the only thing that those share?
The 1. We know the x.
A 1 and an x, yeah. So we can just write x, 1x. And so then x times what gets me back to x squared?
1.
3.
X times what is x squared?
1.
1.
Not 1.
2.
No, not a number. X times what is x squared?
X.
X. Oh, man.
So,
All right,
come
we
on,
have,
Ernest.
remember, we factored out 1x. We needed 2, so we made 1 more. Okay, so then plus x times what is 3x?
3.
Positive 3. Yeah.
Positive 3.
So then we drop that plus, and then what's the GCF of 5 and 15?
3.
3.
X.
And then, oh, this one doesn't have an x. We can't take out an x. Okay, so then 3, wait, I'm sorry, those are not, it's not 3. You're jumping ahead. I was like, this is off. 5 and 15. 5 and 15.
3.
No,
5.
15 goes, or 5 goes into 15 3 times, but 5 and 15, their GCF is
5.
5. Yeah.
5.
So I guess that's where you were jumping ahead on the 15. That's where I just wasn't paying attention for a second. All right, so then 5 times what gets me back to 5x?
X.
1.
Just 1x. Then 5 times what gets me back to 15? This is where the 3 comes in. Positive 3. Which now I have my common binomial. So I would drop that down one time, x plus 3. And then I would get the other one would be x plus 5. Right there. So then you look back on your problem that looks like this, and it's only asking for the length, right?
Mm-hmm.
They gave you the x plus 3. So then your answer would have been just x plus 5.
Oh.
because remember, it's length times width. So they gave you one of the ones, and so it's whichever one they didn't give you.
No, I keep getting it wrong.
Okay, were you trying to put the whole thing?
First I only put the will. Then I put the whole thing. I didn't know I was had to put the length.
Yeah, you just had to put the remember, on these ones, you also didn't necessarily have to do the X method because it's just to remind you of the kind of shortcut whenever your leading coefficient is 1. Let's practice that real fast. So like, let's say we had this same problem and we had x squared plus 8x plus 15. So if you like to use the X method every single time, that's fine. Even with a coefficient of 1, you can. Absolutely can, but you don't have to, okay? So I taught you guys like last week's video was over the kind of shortcut when we have a leading coefficient of 1. Okay, I told you guys we could find the things that multiplied to be C, and then they would, the sign would tell us if they were gonna add or if they were gonna subtract to give us the B. Okay, so since it's a positive 15, then that means they're gonna add to give us the B value. So if we break apart 15 again, we said it was 1 and 15, and then 3 and 5. And so then we said it's positive 15, so again, it's gonna be add to be 8. So the add to be 8 would have been 3 and 5. And then the sign in front of the B tells us the sign of those numbers. So they both would have been pluses. And once you figure that out, you can automatically just rewrite it, x plus 3, x plus 5. So whenever it's a leading coefficient of 1, because there's never going to be a number in front of those x's. So there's kind of a shortcut if you get it, but if you don't, by all means, do what we just did.
Okay.
You can still do the X method every time. But even if you were looking at it like this, it's still, the problem still gave you the width over here. So it only wanted the length. So you still would have just written L equals X plus 5.